you are introduced to this word slash concept that ought to be part of your working vocabulary. What is fallacious reasoning or fallacious argumentation, Mr. Smith?
When it's not logically sound.
Yeah. If something is fallacious, we mean it is, for one reason or another, not logically acceptable. There's a lot more ways that an argument can be fallacious than there are ways for it to be well constructed. So fallacious reasoning is bad reasoning or erroneous reasoning. We will be talking about some subcategories of fallacies, and I may as well mention to you right now. Even though the author does not go into this kind of detail early on, we will be looking at arguments that are formally fallacious in the earliest parts of this course. As a matter of fact, starting later this week. Now, for those of you who have not heard of this before, what we call deductive reasoning is sometimes associated with this word formal logic. The reason why we call it formal logic is because first and foremost, arguments are evaluated in terms of their what? They are first and foremost evaluated in terms of their form or their structure. We call them formal fallacies because there is something amiss in the overall structure of the argument. Now, does anyone want some examples right now of formal logical errors? I hope so, because you're getting them. We will be looking at some very basic constructions from what is called propositional logic very shortly. Propositional logic was developed in the late 19th and into the early 20th century as a method for doing logical analysis that could more adequately deal with real language arguments than the previously often used syllogistic reasoning that we'll also get a little bit of in this course. But let me give you a specific example from propositional logic. In chapters 1 and 2, you will hear of a structure called modus ponens. Now, folks, much of the language of formal logic comes out of what yeah, Mr. Jefferson's got. Yeah, Latin roots. That won't be a test question, but it's one of those things that's worth knowing. Latin was the language of scholarship from the medieval period all the way up into the 19th century. If you were an educated person, you learned Latin. And up until about the time of the French philosopher Descartes, all of your formal professional writing would have been in Latin. It was sort of a universal language of communication among intellectuals in Europe. Anyway, that won't be on the test, but it's of interest. Much of the language, particularly of propositional logic, will actually have Latin roots. Now, modus ponens is a very simple argument containing two premises and a conclusion. It will structurally look like this. If P, then Q, or if you prefer, if P, therefore Q. The second premise simply says, it is the case that P. Can anyone guess what I can conclude? Jimmy?
And Q?
Well, just therefore Q.
Oh, therefore Q. All right.
Just therefore. If it's P, then it's the case that Q. It is the case that P, therefore Q. Now you'll notice that P and Q are variables. They are placeholders. They stand in for context. Because when you evaluate a formal argument for this, let me put this word on the board. When you evaluate a formal argument for validity, take a guess what does not matter. Jimmy?
Whether it is true.
Yeah, the truth value of the premises. That is, the content is not relevant to whether or not the structure is valid or not. Structure is independent of the premises. An argument is well constructed on its own merits. Now, of course, if you put garbage premises into it, you'll get what out? You'll get garbage out, to use that old cliche. But simply because a valid argument form might have false premises does not mean that the structure is invalid. As a matter of fact, it is still a valid structure. It's just that the argument will be unacceptable. By the way, an unacceptable argument will be called unsound. How many of you saw that word somewhere? You'll see it in my notes. An argument that is unacceptable logically for one reason or another, whether it's a problem of structure or a problem of the truth value of the premises, will be unsound. Simply because an argument is unsound will not mean that it is invalid. They're actually two separate issues. Now, suppose I fill in for P and Q context. If it's a wallaby, then it's a marsupial. This animal is a wallaby, therefore it must also be a marsupial. Now I notice nobody is like, gasping because they've suddenly become enlightened. Because this kind of stuff isn't about enlightenment. It's actually fairly basic stuff. You say, well, of course if it's a wallaby, then it's a marsupial. And you know it's a wallaby, therefore it must be a marsupial. This merely formalizes the kind of reasoning that most of us do every day without even what? Yeah, without even realizing it, without even thinking about it. I'll give you another example. Oh, good. I was afraid it was getting later than it was. Another valid structure we'll see shortly is called modus tollens. And then I promise I'll go on from these examples because we're going to be doing more with this shortly. Modus tollens, instead of affirming P, we will actually be negating something. Oh, you're here for the next class, right? Oh, it's okay. It happens. Modus tollens structurally looks like this. If it's the case that P, then it's the case that Q. Oh, I did something differently here. You notice I got rid of the words. And that's one of the things that some of us love about formal logic. Because it is actually a symbolic language. Where what you do is you replace words with the underlying structure. See this little symbol right here? You're going to be seeing it again. This symbol symbol right here, this sideways horseshoe, if you want to call it that, this is the symbol that logicians use to stand in for what we call the conditional relationship. Now, of course, that all sounds fancy Dan. But simply because it sounds fancy doesn't what? Doesn't mean that it is. It's actually quite a simple concept. A conditional statement is simply the word we use for the if-then relationship. This basically says if it's P, then it's Q. Now, depending upon the logic book you use, and by the way, some of you may have actually taken what kind of a class where you may have seen some of this. You might see this in some mathematics classes. Well, why? Because deductive reasoning is, in a way, mathematical. Because after all, mathematics is really all about order, structure, conceptual relationships. I think the main reason why people get scared of this kind of stuff is probably bad education. You know, a lot of people are taught to be afraid of this kind of stuff when it's actually kind of what, once you get used to it. Yeah, it's actually pretty easy stuff once you get conceptually used to it. Anyway, better continue here. Now my second statement, this says if P then Q, my second statement is but not Q. You've probably seen this symbol on your computer keyboard before. Some of you may have thought, I have no idea what this symbol is used for. Well, guess what? It is a symbol that logicians use that symbol, the tilde, is used by logicians to mean it is not, or it is not the case that. So this one says, if it's P, then it's Q, but it's not Q. Can anyone guess what conclusion follows? Yes. Therefore, it's not the case that's P. And to sort of illustrate why this works with an example, let's go back to our wallabies. If this animal is a wallaby, then it's a marsupial. But it's not a marsupial. Well, I can therefore conclude what? It can't be a wallaby. Now there's a very simple explanation for why. But it might give you a headache if you have bad mathematics flashbacks. How many of you guys remember talking about these things called sets? Don't worry, you're not going to be tested on this. I'm just trying to give you a parallel. Sets of things. Well, here I'm really just talking about the set of all things marsupial. Well, take a guess what is part of the subset. Kangaroos, wallabies, wombats, possums. Possums, are they in the... Yeah, no, they're wrong continent, I guess, too. But yeah, you notice if we say it's not a marsupial, we can thereby conclude it's not anything that is part of the subset marsupial. Now looking at it that way, I hope it shows you how basic this actually is. It's actually very basic conceptually. Now of course, does formal logic get more complicated than this? Of course it does, but this is the kind of structured thinking that is the basis of it all. Now, once you get ahead of things. Now suppose I keep this first premise. If P, then Q. But let's suppose that my second premise is it's the case that Q. What conclusion can't I draw? If it's P, then it's Q. It's the case that Q. Take a guess what conclusion I can't draw. Yeah. It's all about the structure, ladies and gentlemen. Now, to sort of illustrate why this structure is invalid, but the other one is valid. With the other structure, if an argument is a valid form and its premises are true, what can you always know? If an argument's form is valid and its premises are true, its conclusion will also be necessarily true. If you have an argument structure and you plug in true premises, and your conclusion turns out to be false, you can know for sure that that argument form is not a valid one. Because a valid structure is like a logic machine. You plug in true premises, it spits out a true conclusion. Invalid arguments will not do this, and this is because there's something wrong with the structure. Now let me use a mundane textbook kind of example. Not that my wallabies were not mundane textbook examples. Suppose that P stands in for, if it's copper, P stands for, if it's copper, then Q, it will conduct electricity. If it's copper, then it will conduct electricity. Well, this here thing conducts electricity. Therefore, it's copper. Why can't you draw that conclusion? Because your experience tells you what? That you know that there's more things that conduct electricity than just what? Than just copper. Its being copper is a sufficient condition for its conducting electricity, but it's not a necessary condition. Its conducting electricity is a necessary condition for its being copper wire, though. Yeah, in other words, simply because it conducts electricity doesn't mean that you can conclude that it's copper. Because suppose this circle represented what? All things that conduct electricity, copper would be only what? Copper would only be one of the things in that class of things. You know, silver, gold, pretty much any metal that does what? Conduct. Yeah, that will give off an ion will conduct electricity. And guess what? There's other things in that list of conductors that aren't even what? That aren't even metals. A human body will conduct electricity. This is just to sort of show you that simply because we know that something conducts electricity doesn't mean that we can draw the conclusion, well, therefore it must be copper. Because this relation, if then, only goes this way logically. It doesn't go this way logically. And if I can make one more little statement before we run out of time, keep in mind that when we have logical statements like this, you cannot infer anything that has not been explicitly stated or can be logically explicitly derived from something. In other words, you can't make any assumptions here without being able to demonstrate why you're able to make that assumption. Now, we are unfortunately 1 minute till time up. The good news is we are not far enough along to give anyone a quiz yet. We are far enough along, however, to give you another what? give you another homework assignment. I will email this to you people. However, I'm going to hand you a homework stub.